Hello, this is iMathit with Samuel Oke. And this channel is dedicated to helping young mathematicians reach their full potential as soon as possible. And it's time iMathit with you again. In this lesson, we're going to be focusing on differentiation. We will solve specific problems where we'll be calculating the differential coefficient of specific functions of s. I will not bother you with unnecessary explanations. So instead, we will focus on calculating the derivative of specific problems where we apply each of these method. We're going to see problems where the first principle applies. Then we will go on and solve some problems where we would apply the standard derivatives in calculating the derivative of specific function. Then we'll go on and see example where sum and difference rule applies. Then we'll see problems where chain rules apply, where product rule apply, and finally we will see where quotient rule apply. Now if you wait till the end, we're going to see a problem where none of these apply, instead a combination of all, and we would apply logarithmic differentiation in solving such problem. In this first example, in this problem, we would need to apply the first principle. We're specifically instructed to calculate the differential coefficient of this function from the first principle. The problem is y equal to x raised to power 2. Remember, y is a function of x, which equals to x raised to power 2. Given s changes by delta s, this is a term we will be using in this lesson. So if s changes by delta s, f of x is 2x squared. So what will be f of x plus delta x? It's going to be 2 into x plus delta s squared. Just put x plus delta s anywhere you see x. Now take this as the general formula for calculating the differential coefficient of a function from the first principle. So the f of x plus delta x minus the f of x, and all divided by delta s. Take this as the general formula to calculate the differential coefficient of any function from the first principle. Like I said earlier, towards the end of this video, we're going to solve a much complex problem using logarithmic differentiation. So wait for it. You may have to pause this video where necessary. So in this particular problem that we are solving here, so what is the derivative of x from the first principle? What is our f of x plus delta s? That is 2 into x plus delta x, 2 plus delta x squared. I just wiped that off, I'm sorry. So and minus 2s squared. 2s squared is the function of x that we had earlier, all divided by delta x. Now to simplify this further, we have a bracket there and raised to a power of 2. So we have to go on and simplify that. Let us express that in other form by repeating that bracket, and minus 2s squared, all divided by delta x. Okay, this equals the limit as delta x approaches 0. So we can go on and open that bracket first, or we can open the bracket in the front first. So let's do this first. So That gives 2x plus 2 delta s. So let's put that bracket there. And minus 2s squared. So all divided by delta x. Okay, we have to open that bracket, applying the distributive law. So the limit as theta is approaching 0. So 2x multiplied by s gives 2x squared. And 2x multiplied by delta s gives 2x delta x. And 2 delta x multiplied by x is 2x delta x. And 2 delta x multiplied by delta x gives 2 delta x squared. And negative 2x squared. All divided by delta x. Okay, let me wipe here so we can have space to continue. This equals the limit as theta x approaches 0. Look up here. So we have 2x squared, and here we can combine this. That is 4x delta x and plus 2 delta s squared and negative 2x squared divided by delta x. Feel free to pause the video so you don't miss any part. Look at these two. Cancel each other out. So what do we have left there? So the limit as theta x approaches 0 would be 4x delta x and plus 2 delta s squared divided by delta x. Okay, now we have to go on and simplify that further. Please hit the subscribe button and ring the notification bell so you don't miss videos like this. So let us simplify this fraction further by splitting them into two smaller fractions. So if we are to express it as the sum of two smaller fractions, this is what we'll have. 2 delta s squared all over delta x. You will agree with me that this will translate as the same as what we have down there. So this, from here, we can go on and cancel out the delta x. And delta s here reduce this. Okay. We have 4x and plus 2 delta x. Don't forget that. Now, as delta x approaches 0, so what happened to the constant we have back there? So the differential coefficient of y with respect to s is going to be 4x, because 2 delta x will be 0 as delta s approaches 0. And there you have it. That is the answer to the problem. That is the solution to the problem. Now let's go on and see another problem. In this case, y equals 1 all over x. Remember, y is a function of x. And the function of x we have here is 1 all over x. And the next thing we're going to need is f of x plus delta x. Hope you remember the formula. So what would f of x plus delta x be? That would be x plus delta x. Remember, I said earlier on that you should just add delta s to x to get f of x plus delta x. So the general rule, the formula, is the differential of y with respect to s from the first principle would be this: f of x plus delta x minus f of x divided by delta x. Okay, what we have to do now is we'll go on and put these values into our formula, then we'll go on and simplify it. What is f of x plus delta x? this is it up here. 1 all over x plus delta x, and minus what is f of x? That is 1 all over x, all divided by delta x. Look at this problem here. Up here we have a fraction, so it's advisable we go on and simplify that first, then we bring it back into the expression. So let's do that up here. We'll find the LCM. That'll be x into x plus delta x, and if we do the fraction, this is what we have. So let us keep that, and we're going to put that there to replace that. Then we go on and complete the rest of the problem. So the limit as delta x approaches 0, x minus x plus delta x, and divided by x into x plus delta x. Let's put that in a big bracket because it's out of my camera frame. So, and divided by delta x. So this is the form, the best form I can write this so that I don't write outside the camera frame. Okay. Please, if you are getting value from this video, remember to give it a thumbs up and hit the subscribe button. Let me wipe this so we can continue with the solution. So the differential of y with respect to s is going to be, so from here, this was all over 1. Let me fill that in first. Here we have x into, I forgot the bracket there, x plus delta x, and all multiplied by, we are trying to change that sign from division to multiplication, and it turned it into the inverse of what was originally at the denominator. So to simplify that further, so we have x minus bracket open x plus delta x all over. So let us join the two fractions. Just for the sake of practice, I am not supposed to be wasting time on this as much as this, but I know some of us might need it. Okay. Now next is we open the bracket up there with that -1 we have on the outside of it. So we have x minus x and minus delta x all over x into x plus delta x and delta x. If you look here, you'll notice these two cancel each other out. So what do we have left? The limit as delta x approaches 0 would be, so negative delta x all over x into x plus delta x and multiplied by delta x. You will notice that this cancel out the delta x we have up here, right? So we have -1 there. Periodically, there will be lengthy video like this, but not all the time. I just want this video to be comprised of every aspect of differentiation you are going to need. So the differential of y with respect to x would be, all we have up there is -1 all over x into x plus delta x. So from here, as you can see, what we have to do now is open that bracket, applying the distributive law. So we have this x squared plus x theta x if we open that bracket. Now, as theta x approaches 0, look down there. So the differential of the y with respect to x is going to be negative 1 all over delta x squared. You notice delta x will be 0 then. And again, there you have it. Okay, let's go on now and get familiar with some standard derivatives. Let's move on from first principle. So I cannot mention all of the standard derivatives you're going to need in this video, but let us just mention some. The derivative of a constant with respect to x is 0. A constant like 0, 1, 2, 3, the natural counting number, negative numbers, etc. Also, the derivative of ax to the n power is an x raised to the power n minus 1. We're going to see examples where this applies. Let's just follow through with this. Also, the derivative of e exponential e constant to the x power is e to the x. Like I said, this lesson is not aimed at explaining how these are obtained. The differential of sin x with respect to s is cos x. The differential coefficient of cos s, mind you, that is cos x, is sin x, negative sin x. Negative sin x. The differential coefficient of tan x with respect to x is sec square s. Sec square x. And so the differential coefficient of ln of x, natural logarithm, that is log to the base of e, ln of x is 1 all over x. Please just take this as basic knowledge that you need to remember every time you have to calculate the differential coefficient of a function. So these are some of the standard derivatives. Now let's go on and see a problem where we can apply this standard derivative. The differential coefficient of ax to the n power with respect to x is an x raised to the power n minus 1. This type applies where y is a function of x in this format, ax to the n power. The x raised to the power n has a coefficient a. Now look at this particular problem. We have y equals 3x squared. You will notice the value of a in this problem is 3 and the power n is 2. It is just as simple as this. So therefore, what is the differential coefficient of y with respect to x? That is going to be 3 multiplied by 2, which is the power, and multiplied by x raised to the power 2 minus 1. If you can see, we simply replicate the formula up there and we plug the values in. 3 times 2 is 6. 2 minus 1 is 1. So there you have it. That is 6x. The derivative of y equals 3x raised to the power 2 is 6x. Okay. Let's go on and see another one. You can pause the video and see if you can find the differential coefficients of all these functions. So, okay, let's do it together. We'll start with the first one. I choose this to expose us to application of the standard derivatives. For the first one, we have y equals x raised to power negative 5. You will see this is of the form y equals ax raised to power n, and the differential is going to be an x raised to power n minus 1. Now what is our a in this problem? The coefficient is 1. And what is the power? N. That is negative 5, right? So therefore, the differential of y with respect to x, the derivative is 1 multiplied by negative 5 and multiplied by x raised to power negative 5 and minus 1. That is going to be minus 5x raised to power minus 6. Just like that. It's a lot of fun. You can see calculating derivatives can be so simple and fun. Now let's go on and see the second one from the list, which is y equal 3x raised to power negative 4. This also is of the form ax to the n power. So what is the expression for the y dx, which is the differential of y with respect to x? This is it from the formula, remember? So what is the coefficient there? That is 3, and the power is negative 4. Let's go on and put these values in. So the expression for the y ds is going to be 3 multiplied by negative 4 and multiplied by x raised to power minus 4 minus 1. This equals negative 12x to the power of negative 5. And there you have it. You will notice that if we have millions of this, we would easily solve them. Now, some of them can be slightly different. Look at this. We have a trigonometric function here, negative cos x. But the standard derivative, like we just learned earlier, when you're having the cosine of x, simply put, the differential of y, or the function with respect to s, is going to be negative sine x. Remember? So this is the rule that applies here. So you can just go on and find the expression for the y dx for that function, and that is going to be negative 2 sine x, and that is going to be 2 sine x. Minus times minus is plus, right? So, and there you have it. Okay, let's go on now and say the last one. I want us to take this step by step. So we're going to see more problem that can be more challenging as we move on. This function has the exponential constant e to the power of x. The standard derivative is the expression for the y ds is going to be e raised to power x. In cases where the x has coefficients, we will apply chain rule, as you're going to see in the future. And there you have it. This is the solution to this one. 3e raised to power x. Just like that. So as we move on to chain rule, we're going to see what to do with it when the power x has a coefficient as we move on. Okay. Now, let us move on to the sum and difference rule. These usually involve addition and subtraction of functions that we are to find the derivative. Okay? This type of function usually looks like this. you have y equals u plus v. You have a function u and function v that is added to give y. So remember, y is a function of x. For this rule to apply, u has to be a function of x, and v as well has to be a function of x. Maybe I don't have to write that. So the expression for the y ds, or the differential coefficient of u plus v with respect to x, is going to be the differential of u with respect to x plus the differential of v with respect to s. In simple language, you just have to be calculating the differential coefficient of individual components of the function and add them up, or subtract them, just as the case may be. Okay, now let's go on and see example of problems where we are going to be needing this rule. Look at these two problems. You can try and pause the video and see if you can solve them. So copy them down somewhere so that you have them handy. Okay, the first one is y equals 2x raised to power 3 minus 4x raised to power 2 plus 6x and minus 1. You will notice that this is just sum and difference of smaller functions that are combined as one, like what we have been doing. So this is of the form y is equal to u plus v. You can say this is of the form y is equal to u plus v plus x plus y. You can say we have 4 of them added up here. So the expression for the y ds is given by this formula, which is the differential of u with respect to s plus the differential of v with respect to s, etc., etc. Just add them all up. So therefore, the expression for the y ds for this particular problem is going to be of this form. You can notice I'm applying the standard derivative. So that will be 4 multiplied by 2, x raised to power 2 minus 1. This will be 6 multiplied by 1 is the power you have there. X raised to power 1 and minus 1. Look at that. We have 1, right? So that is 1 multiplied by, notice you have x raised to power 0 here. So that would be 1 multiplied by 0, x raised to power 0 minus 1. So 2 times 3 is 6, x raised to power 2, and minus 4 times 2 is 8, x raised to power 1. We don't have to write that. And 6 times 1 is 6, and x raised to power 0 is 1. And you can say that that 1 is cancelled. So there you have it. That is the expression for the y dx. That's the derivative of the function up there. So we add them all up, or subtract them as the case may be. Okay, let's go on and see another problem. On this problem, we are going to need different standard derivatives because the components of these functions include trigonometric function, exponential, e to the x function, etc. So y equals 9, x raised to power 3 minus 3 sin x plus 5 cos x minus 3e to the x. So this is of the form y equals u plus v. So the expression for the y ds is going to be the u dx plus the v dx. Simply put, we get the differential of the individual component and add them up. So therefore the y dx is going to be 9 multiplied by the power 3 multiplied by x raised to the power 3 and minus 1. Now, minus 3, what is the differential coefficient of sine x? That is cos x. And plus, leave the constant 5. The differential coefficient of cos x is minus sine x. And let's leave the constant, negative 3. And the differential coefficient of e to the x power is e to the x. Those are the standard derivatives. So those are the standard derivatives. So 9 multiplied by 3 is 27. And x raised to the power 2 minus 3 cos x and minus 5 sin x and minus 3 e to the x power. And there you have it. So that is the new function that happens to be the derivative of the original function. And the question can come in different form. Now let's move on to something very important. Chain rule. Chain rule. These are problems of this form where you have y equals u to the n power. Y equals u to the n power. Remember, u is a function of x. But the function of x has other power than 1, which is the usual. The formula is the differential of y with respect to x in that case is the y du dx. This simply means the differential of y as a whole multiplied by the differential of u with respect to s all by itself. Then you take the product of these two components. Okay, let's go on and see this example. We have y equals 2 all over 3x squared plus 4 in brackets to the power of 7. You will notice that if you want to apply sum and differential, you have to open that huge bracket, and that's going to be demanding. So what we have inside this bracket is going to be our u. So this type of problem is a chain rule type. So let us rewrite that expression in a form that will be easy for us to handle. So I push out the 2 up there off it. So I can go on and apply indices to express what I have in the bracket down there in this form. And this becomes negative 7 from the law of indices. So now you will notice that this is of the form y equals u raised to the power n. So this is the expression we have to go on and differentiate. So in this problem, we've said it earlier on that u is 3x raised to the power 2 plus 4. Now what is y? Let our 3x raised to the power 2 plus 4 be our u. So this becomes 2u raised to the power negative 7, right? So what would be the expression for the y du, the differential of y with respect to u that we have in the new expression? That will be 2 multiplied by negative 7 multiplied by u raised to the power negative 7 and minus 1. 2 times minus 7 is minus 14. So u raised to the power minus 8. Okay. Now we've gotten the y du in terms of u, of course. So what is the expression for the differential of u with respect to x? That is going to be 3 multiplied by 2 x raised to the power 2 minus 1. So you notice 4 is a constant. So let's write it anyway. We have 4 multiplied by 0 multiplied by x raised to the power 0 minus 1. So we have x raised to the power 0 after that 4. So the expression for the differential of u with respect to s is 6x. Okay. Our dy du is negative 14u minus 8, and our du dx is 6s. And you remember our u is 3x squared plus 4. Now these are all we need. We'll just plug these values into the formula. You see, the y du, we put it in the formula, and the uds we put in the formula, and we would obtain the derivative of the function. Okay, now let's go on and do that. So therefore, the expression for the y dx is going to be the y du, which is negative 14 u raised to the power minus 8 multiplied by du dx, which is 6x. Okay, what is u? So we have negative 14 into u is 3x raised to the power 2 plus 4, and multiplied by, we have raised to the power minus 8 there, multiplied by 6s. So let's move that forward and multiply that by negative 14 that we have there. That gives negative 84x into 3x squared plus 4 raised to the power negative 8. There you have it. And that is the derivative of that function. Okay, look at this problem. This is an example where the problem is in a trigonometric form. Y equals sine of 4x squared minus 3. This is also a chain rule type. Our u in this case is 4x raised to the power 2 minus 3. So now the expression for the y dx is dy du, differential of y with respect to u, multiplied by du dx, which is the differential of u with respect to x. So what is the y du, which is the differential of y? So what is the differential of sine 4x raised to the power 2 minus 3? Because that is what that means. Because y equals sine 4x raised to the power 2 minus 3. I'm not supposed to write it in this form right now because we are writing with respect to u and I have x up there. But I hope that did not confuse you. Okay, so the expression for the y du is going to be the differential of sine u, which is cos u. Our u is 4x raised to the power 2 minus 3. I hope you are not confused. So the u dx is the derivative of u, which is 4 multiplied by 2 and multiplied by x raised to the power 2 minus 1 minus, and 3 multiplied by the 0, x raised to the power 0 minus 1. We have x raised to the power 0 there. So we have 8x. Now that's our u. So we have to go on and plug this value. The y du, that's the value, and the u dx, that's the value as well. So let's go on and put that in the formula. So we have the y du, which is cos 4x squared minus 3. Let's write that down. So, and multiplied by the u, the x, which is 8x. We can leave this like this, but better still to avoid confusion. So let us bring that 8x back here. So we have 8x into cos 4x squared minus 3. And there we have it. That is the derivative of that function. So if you see a trigonometric function in this format, you should know that it is a chain rule type. Okay. Please, if you are getting value from this video, remember to hit the like button and please subscribe. Now let's move on to product rule. So this is case where you have y is the product of two functions of x, u and v. So when we encounter problems of this type, the y dx will be solved by this formula. So u dv dx, u multiplied by the differential of v with respect to x, and plus v multiplied by the differential of u with respect to x, du dx. So u dv dx plus v du dx. So please, you should keep this formula at heart as well. Now, let me wipe this off so that we can solve specific problems where this rule apply. Look at this. We have y equals x raised to the power 2 plus 6 and multiplied by 4x squared minus 4 in bracket. You will notice we have two functions here, this and this. So the first one, let the first one be our u, and let the second one be our v, 4x squared minus 4. Okay. Now, the expression for the y dx, which is the differential of the function, is u dv dx plus v du dx. You will notice from this definition that we need to have u, which we have already. We need to have v, which we have already. We also need the differential of v, which is, the differential of u, which is the u dx. So what is the differential of u? That will be 2 multiplied by 1 and multiplied by x raised to the power 2 minus 1. So that is a constant. Let us leave that. So the differential of u with respect to s is 2x. Now we also need dv dx, which is the differential of phi, derivative of phi with respect to x. So what would that be? That would be 2 multiplied by 4 and multiplied by x raised to the power 2, x raised to the power 2 minus 1. Okay, that's going to be 8x. Sorry, I didn't write that properly. Okay, I hope you're not confused. So therefore, let us go on and put all these values into our formula. The y dx equals u. What is our u? X raised to the power 2 plus 6. That is the u we have there. Let's go on and multiply that by dv dx, which is the differential of v, which is 8x. Now we have plus and v. What is v? That is 4x raised to the power 2 minus 4. Let's put that in bracket. And we will multiply that by the differential derivative of u, which is 2x. Okay, so now all we have to do is go on and simplify that. Let's open that bracket. We have 8x into x raised to the power 2 plus 6 and plus 2x into 4x raised to the power 2 minus 6. Let us leave it in this form. So this is satisfactory enough. You can go on and open that bracket if you want to. So there you have it. So that is the derivative of that function. So this is a product rule type. Okay, let us go on and see another problem. This is y equals 3x raised to the power 3 cosine of x. Let us keep it simple. So you will notice this is also a product of two functions. So let the first one be our u, 3x raised to power 2, and let the second one, cos x, be our v. The expression for the y dx is u dv dx plus v du dx. Okay, we have obtained our u and our v, but we still need the derivative of v, which is minus sine x. The derivative of cos x is minus sine x. We also need the derivative of u, which is 3 times 2 x raised to power 2 minus 1, which is 6x. So what we just have to do now is put this value into the formula. Therefore, the y dx equals u. You can see up here, our u is 3x squared. And what is the v dx? The differential of v with respect to s, derivative of v, is negative sine x. And plus, what is v? Cos x, and multiplied by the derivative of u, which is 6x. And let us try to write that in a more comprehensive form. So 6x into cos x. And there you have it. That is the derivative of that function. So you will notice in these examples we have product of two functions. Okay? Now let me wipe this off. Now let's go on and see the very last type of problem that I mentioned earlier on, which is the quotient rule. What is the quotient rule? This is the type of differential. When you have y equals to a quotient that is made up of two functions of x that are quotient, remember both u and v must be a function of x. So when you have y equals u over v, when you are dividing the two functions, then the expression for the y dx is going to be v du dx minus u dv dx all over v squared. I hope you understand what this implies. You will obtain v, the derivative of u, the derivative of v, and you square v. You should remember this formula. And that is, you should also know that u and v has to be a function of x. Please remember this formula. It's essential. We don't actually need to memorize all this, but we just know them. And when the problem present themselves, we apply them. We gain mastery through practice. Okay, let's go on and see this problem. Find the differential coefficient of this function. Y equals 2s squared plus x and minus 1 divided by sine x. Okay, you will notice that this problem is a quotient. Up there we have a function of x, and down here we have another function of x. So let the one up there be our u, that is 2x squared plus x and minus 1. Let the function down there be our v, which is sine of x. Okay, what's the expression for the y dx? the formula is v du dx minus u dv dx all over v squared. As you can see, we have obtained our u and our v already, but we would still need the differential of u and the derivative of v. So the derivative of u with respect to s would be 4 times 2 times 2, which is 4, and x raised to the power 2 minus 1, which is 1. And the derivative of x is 1. Now I am beginning to skip steps. So from the examples we've seen so far, I hope you are not confused and you remember how we have been doing it. The derivative of v with respect to s is simply cosine of x. Remember from the standard derivative. Okay, what is v squared? You know, that would be sine squared x. Sine s squared is sine squared of x. So therefore, let us go on and put all that into this formula. So what is our v? Sine x, right? And the differential derivative of u with respect to s is 4x plus 1 minus u, which is 2x squared plus x and minus 1. We should put that in a bracket to avoid ambiguity. So, and what is the expression for the u dx, which is the derivative of u, that is cos x, all divided by v squared, which is sine squared of x. You will notice that these problems are very easy to solve. So we just have to obtain the values and plug them in. So you can go on if you want to and simplify that further, but that is satisfactory enough. Okay, now let's go on and see another problem. This one is much easier, much simpler and straightforward. We have y equals x plus 3 divided by x minus 1. We have to obtain our u. So let the expression up there be u and the one down, the denominator, be v. So what is the formula? The y dx equals v du dx minus u dv dx all over v squared. We have to go on and obtain our du dx, which is the derivative of u. You know, that would be 1. 3 is a constant. And the derivative of v with respect to x is 1 as well. So the negative 1 is a constant. Okay, now what is v squared? That is x minus 1 squared. And just like that, all we have to do now is put that into the formula. So the y dx is v, which is x minus 1, multiplied by the differential of u, which is 1. I am not supposed to write that, but for the sake of practice, let's just write it because some of us might need it. And minus u, which is x plus 3, and multiply by the v dx, which is 1. For the sake of practice, let's write that too. All over v squared. So we just have to go on and simplify that expression. So if we open the bracket up there, that's what we have. Now we can go on and combine what we have there. X minus x is gone, and minus 1 plus 3 is minus 1 minus 3 is negative 4. So all over x minus 1 squared. And there you have it. So that is the derivative of that function. Now, by now, we have seen several problems. Now let us go on and see a problem that is much different. Here, chain rule, product rule, and quotient rule all will be required to solve this problem, because we are having three different functions in one. You will notice that y is a function containing u, v, and w in this form. So y is equal to uv over w. You will notice there is no specific formula for solving this kind of problem. So but let's go on and obtain our u, our v, and our w. So our u is 3e to the 2x, our v is sine x plus 1, and our w is cos 2x. Okay, I think we should go on then and get derivative of each of those functions. Derivative of u with respect to x, you will notice that is a chain rule problem. So that is 3e to the x and multiply by the differential of u, which is 2x in that case, excuse me. So that is why we have that multiplied by 2. When the e to the x has a coefficient, you get derivative of the power as well. So what of the derivative of v for sine x plus 1? It is cos x plus 1 multiplied by derivative of x plus 1, which is 1. And that is why that is simply x plus 1. And the derivative of w with respect to x is going to be negative sine 2x. So I multiply by the derivative of 2x, which is 2. So there will be dedicated video on this channel to clarify chain rule better. There would also be a dedicated video for product rule as well. So we have all these values. Now to solve this problem, it is important that we convert this problem into a form that will be much more easier for us to solve. Look at the numerator, we have a product up there, and in the same problem we have a quotient. So our y is uv over w. You see this numerator, let us put it together as a single term. So let our uv be t, such that our y would simply be t over w, and then we can use quotient rule to solve the problem. So therefore the expression for the y ds is going to be w, the t, the x, I hope you understand this, minus t, the w, the x, all over w squared. You notice this is the form. This is the form from the original formula. Now we have converted this now into a simpler form by combining u and v as a single term. So we're going to solve that when we are to calculate the derivative of t, the t dx. So what is the t ds, which is the derivative of t with respect to y? Mind you, t is u times v. So you're going to apply product rule there. So the t dx is going to be u dv dx plus v du dx. So we apply product rule to get the derivative of t. You notice t is a product of two functions. What is u? 3e to the 2x power. And what is dv dx? That is cos x plus 1. And plus, what is v? V is sine of x plus 1. And I should put a bracket there. What is our du dx? the derivative of u, that is 6a raised to the power 2x. Okay, now all of this is the expression for the t dx. Now let's go on and put these values in. So we've gotten the expression for the w dx already. So our w squared is simply squared of w, right? So please keep all this somewhere. You can copy it somewhere so that you won't get confused by the time I start to input the value, because I just have to wipe the board now so we can have space. So the expression for the y dx equals, so w. So what is w? So okay, let's take it slowly. What is w? W is cos 2x. Now, what is the t, the x? That is everything we got there. So let us go on and put that in. Please give this video a thumbs up if you are getting value from this video, and remember to subscribe for more educational content like this. As a matter of fact, this is not the best method for solving this kind of problem, but for the sake of practice, that is why we are doing it. We will go on and solve it using a much suiting method, a more suitable method. Okay, now that is not all, and minus is the next thing. So look at the formula. So minus, so, and t. What is the expression for our t? The expression for t is u multiplied by v. U is 3e raised to the power 2x, and v is the sine of x plus 1. Now we would multiply that by the w dx, which is the derivative of w. If you keep the note that we write earlier on, you can check from the note. So all of this, the whole thing, all over, that's divided by w squared. So and what is w squared? That is the cosine squared of 2x. So if you can go on striving to simplify that further, but this is the answer, this is the solution to this problem. Now you will notice that this result is not very well conclusive. So that is not the most suitable method for solving that kind of problem. I promised earlier on that we are going to see logarithmic differentiation at the end, and this is it. This kind of problem we solved last is better solved using logarithmic differentiation because it involves chain rule, quotient rule, and product rule all in one. To avoid that confusion, we should use logarithmic differentiation. The problem is y equals 3e raised to the power 2x multiplied by sine of x plus 1 all over cos 2x. Now let us go on and solve this problem now using logarithmic differentiation. We might get an answer that appears different, but in the long run, if you break them down, you will arrive at the same thing. Let us introduce natural logarithm to both sides. It's advisable you use natural logarithm. You can use any logarithm of choice, but since we have exponential e in the problem already, natural logarithm would be the best for this kind of problem. So we have ln of y equals ln of, big bracket open, 3e raised to the power 2x multiplied by sine of x plus 1 all over cos 2x and big bracket closed. Now we should open that big bracket there to write a problem in a form that will be easier for us to solve. So we have ln of y equals ln of 3 e raised to power 2x plus ln of sine of x plus 1. I got this from the rules of logarithm. So you can go on and check the rule of logarithm, refer to your textbook. So to recap that, just in case you have forgotten the rules. So now this is the expression, this is the equation we have to differentiate now. Now let us differentiate both sides. That is, let us find the expression for the y ds for both sides with respect to x. So that would mean we want to find the ln of y dx. So a little bit of sum and difference rule apply here. The ln of 3 e raised to power 2x plus ln of sine x plus 1 minus ln of cos 2x. dx with respect to x. So let us solve this at once. If you're having the differential of y with respect to x, it's going to be 1 over y. But since we are differentiating with respect to x and you have y in your problem, so you multiply it by dy dx. So this equals, let us go on and split that from sum and difference rule. So we have the ln of 3e raised to power 2x with respect to x plus ln of sine x plus 1 with respect to x minus ln, the ln of the cosine of 2x that is out of the video frame, I suppose. So the ln of cosine of 2x with respect to x. Okay, so we just have to go on and get those values to complete this problem, to complete the solution to this problem. There will be a dedicated video to logarithmic differentiation on iMathit on this channel. So 1 all over y multiplied by dy dx equals, so what is the derivative of ln of 3e raised to power 2x? This is a chain rule problem. The derivative of ln of anything is 1 all over that function, now multiplied by the derivative of the function. So here we have 3e to the 2x. So that's a kind of chain rule problem inside a chain rule problem. So you have 2 times 3 e raised to power 2x. Let us put all over 1. So what we are doing will be clear. So plus, we have the ln of sine x plus 1. So that's another chain rule problem. So we have 1 all over x plus 1. So we are going to multiply that by, so the derivative of sine x plus 1, which is cos x plus 1, and multiplied by 1, which should be cos x plus 1. And minus 1 all over cos 2x and multiplied by negative 2 sine x. That is the derivative of cos 2x. So we have 1 all over y multiplied by dy dx equals that, cancel out that, and that cancel out that too. So what do we have left in that expression is 2 and plus. So there, let us write that in this form, cos x plus 1 all over sine x plus 1 and plus 2 sine x, sine 2x all over cos 2x. Okay, now from here on we should remember that the sine of theta over cos of theta is tan of theta. So I hope you remember this in trigonometry. And the cot of theta is 1 over tan of theta. So which looks like what we have up there. So we should not forget this out as well. So let us go on and rewrite those in a better form. So let me wipe this so we can have space to continue. You will notice this problem is more complex. That is why we are doing it last. So 1 over y multiplied by the y dx equals 2 and plus. So cos x plus 1 over sine x plus 1 is going to be cot x plus 1 and plus, so 2 sine x plus 2 over cos x plus 2 is going to be tan x plus 2 because sine theta over cos theta is equal to tan theta. And there we are. Now to remove this 1 over y from here so we can have the expression for the y dx, let us multiply both sides by y so we can eliminate the y from the left hand side. Okay, now we'll go on and multiply both sides by y. Okay, so we are going to be having y multiplied by 1 all over y multiplied by dy dx equals y multiplied by 2 plus cot x plus 1 and plus 2 tan 2x. So that cancel out each other. So we have the expression, but first of all, let's recap. What is our y? So if you are keeping notes, you remember our y equals 3e raised to the power 2x sine x plus 1 all over cos 2x. So let us go on and plug in the y into the expression for the y dx. So we have 3e raised to the power 2x multiplied by sine x plus 1 all over cosine of 2x and all multiplied by 2 plus cot x plus 1 and minus 2 plus 2 tan 2x. And there you have it. Plus, and there you have it. So That is the expression for the y dx. So this will be the end of this video for now, and I hope you get a lot of value from here. This is iMathit. Please hit the subscribe button and like. And until next time, please keep winning and mathing it. Bye.